Does anyone recognize this? Does it bring back any memories? It does. Good. This is the introduction to a TV series called Once Upon a Time Man. And this was my absolute favorite show when I was a kid. It's originally French, but it aired in almost all of Europe. And whenever my mom took me to rent a video, because that's what you did back then, I would rent an episode of this. This show teaches kids about life. It teaches kids how life was created with the Big Bang and how it has evolved ever since then. Because that's our job as kids. Our job as children is to learn these tiny facts. How did we get to where we are today? So that we can use these facts when we grow up. As adults, our job is to use these facts and try to do what we do just a tiny bit better every day. So think about your code, for example. Is the code you're writing today, is that any better than the code you wrote yesterday? It should be. And what about the lifetime of the code you're writing today? Is that any better than the lifetime of the code you wrote yesterday? It should be. That's what we're going to talk about for the next hour. We're going to talk about the life expectancy of your code. And does it actually increase? Or is this just something that we tell ourselves to sleep better at night? Now, some of you, based on this title, you might be expecting me to give you some absolute answer. I mean, what is your actual life expectancy of your code? So I'm going to give you a formula. I'm going to tell you how you can calculate the life expectancy of your code. And here you go. This is properly researched, I promise. If you take the number of lines of code of your code base, and you divide it by the IQ of the developer minus the IQ of the project manager, you take that number and you do a modulus, the average number of coffee cups you drink per day. You take that number and you add it to the years of programming experience in your project team and divide it by the number of layers of abstraction in your code base. And that's going to give you the life expectancy. I'm not making this up. So let's look at an example. We have this. In this code base, we have 5 million lines of code. The IQ of the developer is about average, 115. The IQ of the project manager is, of course, a bit less. It's 110. 3 coffee cups per day, and 16 years of programming experience with 3 layers of abstraction. That's going to give us a life expectancy of 6.33 years. That's 6 years and 4 months. That's not a lot. So we want to improve this. We want to improve this life expectancy. What do? Any ideas? More coffee? OK. Anyone else? Huh? Less code. OK. Well, I would start out by increasing the IQ of the developer. Try replacing the developer with another one. See what happens. So let's try to increase the IQ of the developer to 140. That's pretty good. And the number of years is going to increase to 7. So that didn't really help. That didn't really make a large difference. But you mentioned coffee. What happens if you drink more coffee? Well, if we double the number of coffee cups we drink, it increases to 9 years. So that's what we have to do. We all have to drink more coffee. And as I said, this is properly researched. This is not something I just made up. But if you do not believe that there is an absolute formula, then I'm going to tell you the conclusion of this talk right now. So if you think this is boring, you can see the next slide and you can go. Because I believe that the overall life expectancy of code is decreasing. And I believe that is our fault. I've been thinking about this for quite some time now, and I don't really know where I got this idea. I guess it's been from working with code, seeing how my colleagues work with code, seeing how code is treated on GitHub, how developers discuss code on Twitter. But I have this feeling that things are going down, things are going to hell. We're doing our jobs a bit worse every day. But of course, I don't have any data to back this up. That was the problem. I just had this really pessimistic feeling, but I didn't have any data. So I might actually just be a crazy person who lost belief in developers. And how do I make sure that I'm not wrong? Well, what I did was, I decided to create a survey. Let's create a survey for developers and see what happens. And I was just crossing my fingers, hoping that the result would prove me right. Or else I wouldn't have anything to talk about right now. So I created a survey, a very short one, 9 simple questions. I posted a link on Twitter, and the survey was open for 5 days. I received 291 responses, which was a lot more than what I had expected. I had expected about 50. So if any of you contributed, thank you very much. I owe you a beer, but I'm Norwegian, and beer is expensive, so yeah. One of the first things I asked in this survey was this. Somewhere out there, a piece of code I wrote 10 years ago is still in use in the production environment. Put your hand up if this goes for you. Who has 10-year-old production code? OK. It's quite a lot. That's good. Here are the results. .1% of the respondents have 10-year-old production code. 6.2% do not. 11.4% don't know, because of course, if you're no longer working with that code and you're no longer part of that project team or talk to the colleagues that you used to have back then, how are you supposed to know? And 20% didn't write code 10 years ago. The second thing I wanted to know was this. I believe the code I'm currently writing will still be used in the production environment 10 years from now. Raise your hand if you believe that the code you're working on right now is going to be in production 10 years from now. Guess that's roughly the same amount, I think. Here are the results I received. 62.7% believe that their code will still be alive in 10 years. 35.9% they don't know, and 1.4% are not writing any code. So this is all good. I mean, this is statistics, but it doesn't really tell us anything. It's interesting, but it doesn't help us. So what I want to do is I want to try to break this down further and see how these two questions relate to each other. Divide them up. So here's the same statement. I believe the code I'm currently writing will still be used in the production environment 10 years from now. But now I've divided up the answers into 2. On the left-hand side, you can see the developers who do have 10-year-old code in production. And on the right-hand side, you see the answers of those who don't. And you can see that the answers are quite different. Almost 70% of the developers who have 10-year-old code in production believe that the code they're currently writing will survive for 10 more years, while only a bit over 50% of the developers who don't have 10-year-old code in production believe that the code they're currently will survive for 10 more years. So there's a difference here. Now, based on these statistics, we can conclude that having 10-year-old code in production increases the belief of code surviving. We don't know why. It could be because of the number of years of experience. I mean, if you have 10-year-old code and you expect to still be writing code 10 years from now, you have over 20 years of experience, which of course means that your code should be pretty good, right? So we don't know why, but we can conclude with this. Now, I'd like to talk about something completely different for a couple of minutes. I want to talk about the life expectancy of human beings in Sweden. Life expectancy of human beings in Sweden has steadily increased for the past 200 years. You see the graph here. There are some low points. There are 4 low points when there was not good to be alive in Sweden. You have 1773, there was a famine due to failed crops. 1809, you had a Dano-Swedish War. 1857, there was a financial panic, and of course, World War I. But apart from these 4 points in time, life expectancy in Sweden has increased for 200 years. And these statistics, they're roughly the same for most of Europe. But the question is why? Why is life expectancy for human beings increasing? And it's still increasing. We're over 80 years right now, and it's still increasing. Well, it's increasing because of our support systems, the support systems surrounding us, like our living conditions. Our living conditions have improved. Most of us have proper housing. We have houses that keep us warm. We have houses with proper sanitation systems, with access to clean water, and all of these things makes us live longer. We have public health offerings. Think about medicine. You didn't have antibiotics 250 years ago. You do now. You have vaccination programs. You have a focus on nutrition, how to give your body what it needs. And of course, we have free healthcare, because you do in Scandinavia. Healthcare is free, it's for everyone. And of course, you have education. Why does education improve life expectancy? Because it teaches you not to do things like this. So our bodies haven't changed much. I mean, our bodies are practically the same now as they were 200 years ago. There are slight differences, but all in all, we have 2 arms, we have 2 legs, we have a head. Not much has happened. We haven't really evolved much. So the thing that has made us live longer, it's our support systems, the things surrounding us, the things I just listed. Can we see the same thing for our code? Is the same thing happening for our code? Let's look at some of the support systems we use every day. And I'm just going to call it our tool set or toolbox. Those people who believe that developers simply sit down on their keyboard and write code all day, they're dead wrong. That's not what developers do. Yes, we write code, but a huge part of our job is being able to use lots and lots of different tools, understanding how we can use these tools to improve our own code. In this example, we have version control, we have testing, we have build servers, refactoring, deployments, documentation, performance, monitoring. There are tools, plenty of tools for all of these. And the list goes on and on and on. I mean, this is just a short list. You could extend this list forever. So imagine for your next project, imagine you were not allowed to use these tools at all for your next project. And you can include Google and Stack Overflow. We're not allowed to use any of them. What would that do to your code? would your code be as good? I see some nodding. That's impressive. I know that my code would not be as good if I were not allowed to use all these tools. So these tools, do they improve the life expectancy of our code? Do they help our code live longer? I had to ask in my survey, of course. I couldn't just give you my answer. You want to know the statistics. So I asked this. The tools I use daily in my development process, such as automated testing, build servers, refactoring tools, etc., help increase the lifetime of my code. 85.5% of developers answered true. So yes, according to most developers out there, our support systems help increase life expectancy, just as the support systems around us as human beings have increased our life expectancy. But hold on. I started this presentation by saying that the overall life expectancy is decreasing. Yet here I am saying that the tools are helping us increase life expectancy. That doesn't make sense. So where's the catch? Who's the bad guy? We're the bad guys. Us. The developers. You, me, we're all the bad guys. Because we have forgotten our responsibilities. We have forgotten our responsibilities, and we no longer view our code as science. We view it as our personal playground, where we can have fun. Of course, our jobs should be fun. I'm not saying we should be bored, but we shouldn't have that much fun. Instead of fine-tuning existing code, instead of analyzing it, trying to understand how it was written and why it was written in exactly that way, we want, or we have developed a habit of throwing it away because we want to write our own. We want to do it our way. We don't want to work with someone else's code. We want to rewrite it. I wanted to find out how quickly developers are to rewrite code. So in my survey, of course, I had to ask a question about this as well. And I asked this. In the past 6 months, I have suggested to my team or the product owner that we rewrite an existing piece of code instead of spending time debugging and fixing it. Is this familiar? Should be. 69.7% of developers said true. That's a lot. In my opinion, that is a lot. I'm only asking within the past 6 months. What would the result have been if I had asked within the past year or within the past 2 years? The number would probably have been higher. But I'm only asking, have you suggested a rewrite? According to this, we don't know how many people actually rewrote that code. So I had to ask about that as well. In the past 6 months, I have rewritten an existing piece of code instead of spending time debugging and fixing it. And it's roughly the same. We went from 69.7% to 64.5%. So it's still a high number. It means that a majority of developers out there are rewriting code instead of debugging and fixing it. But there's nothing wrong with that, is it? Is there a problem with rewriting code? No, we do it all the time. That's part of our job. is to make things better. If the code that was there was crap, why shouldn't I just rewrite it? But what about the rewrites that happens for selfish reasons, for lazy reasons? Those developers who just can't bother. How many of them are there? So I ask this. I have advised that a piece of code should be rewritten simply because rewriting it would be easier than having to figure out how the original code worked. I'm not asking because it's more cost efficient. I'm not saying because it's going to increase productivity on the project. I'm not saying we're rewriting this code because the project owner wants it. We're saying because it's easier for the developer. It's pure laziness. Well, 60%. We went from 69% who had suggested a rewrite to 64% who had actually rewritten code. And then 60% of them have rewritten code simply because it's easier. And remember all those developers out there who believe that their code will still be alive 10 years from now? The statistics were roughly the same for them. But isn't expecting your code to live long while being quick to rewrite code, isn't that somewhat contradictory? I mean, doesn't that increase the chances of someone else looking at your code, thinking, this is crap, and rewriting it before your code even makes it to its 10-year anniversary? So most of us are quick to rewrite. We all do it. I do it. You probably do it as well. But is it always worth it? Being able to maintain someone else's idea alongside of your own is what separates a great developer from an average one. This was made as a comment on my blog, and I haven't been able to identify the person who wrote this. So if you're out there, please let me know who you are. But I absolutely love what he or she is saying here. We have to realize that there is value in understanding what already exists. Instead, or before we start making calls about its limitations. We know that legacy code has value. And we also know that rewrites has a cost. So is it really worth it from a productivity perspective to solve the same problem twice? Sometimes it is, but sometimes it's not. One of the things that leads to unnecessary rewriting of code, that's our fascination of new shiny toys. We are so easily mesmerized by new shiny toys, new shiny frameworks, new shiny libraries, new shiny languages, new shiny coding styles, that we want to take what we have and we want to rewrite it using all of these new shiny things. I want to rewrite this in a new language. I want to make it functional. I want to rewrite this using a newest version of this library, or using a different library. There's a Swedish developer. I'm not sure if he's here today. His name is Daniel Berg, and he calls this developer ADHD. I'm sure you recognize this. This is a tweet that he tweeted some time ago. And you've launched something. It's been there for a while. It's finally stable, and you see the number of bug reports has started to decline. But then we come along, us, the developers. We heard about this new shiny thing. We just want to try it out. And then we're back to square one. We're back to increasing numbers of bug reports. because of our fascination with new shiny toys. I have a friend of mine. It's always a friend, I promise. It's not me, it's a friend of mine. He's been working with a client for quite some time now. And when he started out with this project, their front end was written in HTML, CSS, and JavaScript. I think they were using jQuery. It didn't take long before Knockout.js came along. And the developers looked at it, and they thought, wow, this is really cool. This is so powerful. This is going to make our front-end code really awesome. So they rewrote their entire front-end code using Knockout.js. And everyone were happy. But then, not long after, Angular.js came along. The developers, of course, were so mesmerized by Angular.js, and they thought, wow, this solves all the problems that we're currently having with Knockout.js. It's so powerful. It's even more powerful. So let's start rewriting it. Let's throw out Knockout.js, and let's rewrite it using Angular. And they started doing that. That's not a very efficient way of working, is it? If you're going to rewrite your code every time a new framework comes along, you're going to do a lot of rewriting. Of course, I had to ask about this in the developer survey as well. So I asked this. I have replaced a third-party library or framework simply because I wanted to try it out. Not because it benefits the customer or the product owner, not because it's faster or better, but simply because I wanted to try it out. 35.5% of developers said yes. That scares me a bit. That makes me really scared. But I'm part of the statistics. I've done this. I'm part of that 35.5%. I answered the survey myself as well. I had to do that. New shiny things, they involve risk. We all know it. We all know that the risk is there. When we look at this new shiny thing and want to try it out, we all know that there's risk. There's risk of bugs. There might be bugs that haven't been found yet. And you might be that one lucky developer who finds the bug that no one else is able to replicate. That always happens when you try something new, right? Or you might introduce bugs yourself when you're rewriting your current code using this new shiny toy. And what happens when you find this bug? Well, you're going to need developer support from the people who created it. But do they even have developer support? You didn't know that. They might not have it at all. And what about the knowledge on your project team? Just because you like new shiny toys, did that mean that your colleague knows those same frameworks? Has he or she actually sat down and learned the things that you have? That's a risk. What happens if you're hit by the bus and your colleague has to sit there and maintain your code? There is, of course, the chance of this new shiny framework being completely changed or discontinued. We've seen that happen lots and lots of times. And then you're stuck with a bill. What do you have to do? Well, you either have to keep that version forever, or you have to replace it. So introducing new shiny things in our projects, that should be done on a strategic level. It should be done by the architect. The project owner should agree. It should not be done because one simple developer wanted to try out something new. We can do that on our own time. We can do that on our personal projects. Again, we have forgotten our responsibilities. We have forgotten the science involved in writing code. Instead, we view code as our personal playground. It's there so that we can have fun. And we introduce new frameworks, we introduce new libraries, we introduce unnecessary risk in our projects without considering all the risk. Essentially, what we're doing is we're calling time of death on our code. In the ER, in the emergency room, doctors don't call time of death on a patient before they're absolutely sure that there's nothing more that can be done. They do numerous attempts of resuscitation, trying to bring the patient back, right? Yeah. Developers, we call time of death all the time. We rewrite code all the time. We throw it out all the time. And we do it for various reasons. We can look at a piece of code and we can say, nah, this is not pretty enough. Would a doctor do that? I hope not. We can look at a piece of code and we can say, you know what? I can write this better. I can make this more loosely coupled. I believe this code needs more abstractions. Or I believe this code needs less abstractions. Or my favorite one, it's not readable. I want to make something clear. There's a difference between unreadable code and unreadable code. Major difference. The first one, unreadable code, is code that is not clear enough to be read or interpreted. So in this case, the code is the problem. Then you have unreadable code, where the reader does not possess the required knowledge to read the code. You see the difference? In this case, the reader of the code is the problem. Just because you're not able to read Shakespeare does not mean that you should burn all his works and try to rewrite them on your own. You should try reading more Shakespeare. So, back to time of death. When is it appropriate to call time of death? We have a ton of reasons why we do it, but when should we actually call time of death? When should we start rewriting it? Or when should we just throw it out? Should we do it when it's unreachable? When it's dead? When it's deprecated? Or when it's legacy? Let's start with unreachable. What is unreachable code? Unreachable code is code that exists, but it's never executed. That's a complete waste. So of course, you should call time of death on unreachable code. There's no point in having code in your code base that is never executed. What is dead code? What's the difference between dead and unreachable code? Well, dead code, that is code that is actually executed. But the result of that execution, that's never used in any other computations. So here you're just doing lots and lots of work, and then you're not using it. So of course, yeah, that's useless. Call time of death on dead code. What about deprecated code? Deprecated code is code that is superseded or obsolete. It's code that should be avoided by other developers, and the only reason it's there is because there because of backwards compatibility. So of course, deprecated code, it needs to exist for some period of time. But what you're essentially telling other developers is that we are going to call time of death on this code at some point, but we're just not sure exactly when. So you should call it when it's appropriate. At some point, you are going to call it. What about legacy code? This is my favorite, because there's no answer. Knowing when you should call time of death on legacy code, that completely depends on your definition of what legacy code is. Because what is legacy code? If you tell your colleague or a fellow developer that this code is legacy, they're going to know exactly what you mean. They're going to get your message loud and clear. But have you ever tried asking someone what is legacy code? Have you asked them to define legacy code? You're going to get anything in return. Those who have read this book, Working Effectively with Legacy Code by Michael Feathers, they're going to tell you that legacy code is code without unit tests. I prefer his other description of legacy code. It's in the same book, where he says this: legacy code is code from the past. It's maintained because it works. But for people who deal with it day in and day out, legacy code is a Pandora's box. Sleepless nights and anxious days, pouring through bad structure, code that works in some incomprehensible way, days adding features with no way of estimating how long it will take. Who's had this feeling? Almost everyone, yes, because this is what it feels like to work with legacy code. He describes the feeling of working with legacy code so well. But he's still not able to give us an absolute definition of what legacy code is. Because that's what I want. I want an absolute definition, so that if I were to show a piece of code to 1,000 different developers and ask them, is this legacy? Every one of them would give me the same answer. I want one definition of legacy code. I had to ask about legacy code in my survey, and I asked this: in your opinion, what makes code legacy? And for this question, the respondents were allowed to choose multiple answers. That's why these numbers don't add up to 291. And you see that there is an option that's called Other. If you chose the Other option, you had to supply your own definition. You probably know what's coming next, right? So 13 people believe that it's legacy if someone other than I wrote it. Okay, good for you. 57 people believe that it's legacy as soon as it's in production. 102 people believe that it's legacy if everyone who wrote it are no longer on the project. 115 believe it's legacy if it lacks unit tests. So 115 people read Working Effectively with Legacy Code. 180 people believe it's legacy if it's written in an old language or uses old libraries and frameworks. 77 people believe that all code is legacy after X number of years. And 63 people answered Other. So how did they define it? Here's one. It's It's legacy if you're scared to touch it for whatever reason. And there were multiple answers that were similar to this one about developers being afraid, developers being scared, or being nervous. I had no idea our profession was this terrifying. But the problem is, I want an absolute definition. I want one definition that applies to everyone. But if I look at a piece of code, I might think that that piece of code is absolutely terrifying. But then my colleague might look at the same code and say, that's fine. So that's not an absolute definition, because I think it's legacy and he doesn't, according to this definition. So that's why I don't like this definition. Let's try another one. It's legacy if the code is there, but the meaning is not. This is a deep one. I mean, we all know that the meaning of life is code, but what's the meaning of code? I might look at a piece of code and see one meaning, and you might see that same piece of code, and you might see a different meaning. So answering what the meaning of code is, that depends on the eye of the beholder. So let's try another one. Every time I open a file and it's not empty, it's legacy. I feel a bit sorry for this developer. Maybe they should get another job or work on a different project. What they're saying here is that all code is legacy. As soon as I type or write some code and hit save, it's legacy. And I don't want that. I just don't want that to be the case. If all code was legacy, why would we even need the term legacy? We could just say code, and we would all be like, whoa. So, no, I don't want this. Let's try another one. What about this one? It's legacy when there is no reasonable upgrade path to a modern system. I think that if I were to show you code where this was the case, where there was no upgrade path to a modern system, and I asked you, is this piece of code legacy? I think most of you would say yes. I know I would. So far, this definition is all right. The problem is, haven't we all seen code written in the most modern system that also counts as legacy? It could be written in the newest, shiniest framework there is, and it's still legacy code. That's why this definition doesn't work for me either. Because legacy code can be rewritten, or can be written in modern systems. So how would I define legacy code? I had a hard time with this one. And it's, well, here's the result. I believe that code becomes legacy when continuing maintenance becomes more expensive than rebuilding or rewriting it. The question is this an absolute definition? Probably not. You could probably find use cases where this doesn't work either. And that's the problem with the term legacy, that there is no absolute definition. So going back to this, when should we call time of death on legacy code? Well, that totally depends. That depends on what your definition of legacy is. The really interesting question then is, we've been talking about how quick developers are to rewrite code, and we've been discussing legacy code as well. Is there a correlation between the two? Is there a connection between your definition of legacy and how fast you rewrite code? Let's see. Let's take a look at the willingness to rewrite code. Out of those who believe that it's legacy if it lacks unit tests, 62% have advised that a piece of code should be rewritten, simply because rewriting it would be easier than having to figure out how the original code worked. 62%. Of those who believe that it's legacy as soon as it's in production, 73% have advised that a piece of code should be rewritten because it's easier. So there's a slight increase. Of those who believe that it's legacy, if someone other than I wrote it, 92% have advised that a piece of code should be rewritten simply because rewriting it is easier than having to figure out how the original code worked. So it turns out that your definition of legacy, that actually impacts the life expectancy of your code. It impacts how quick you are to rewrite code. Let's sum up the facts so far. We know that the support systems and the technology surrounding our code, we know that that helps us increase the life expectancy. At the same time, we know that having old code or having 10-year-old production code, it increases your belief of the code you're currently writing of surviving. We know that most of us are quick to rewrite rather than fix code, and of course that decreases the life expectancy. We view code as our playground, introducing risk, which also decreases the life expectancy of our code. And we know that your definition of legacy impacts the life expectancy of the code that you're writing. This is why I believe that the overall life expectancy of code is decreasing. So how do we change this? How can we turn this around? We can start out by building a strong foundation. There is absolutely no point in building a house on a weak foundation. That house is going to fall apart at some point. And the same goes for our code. There is no point in writing code if the foundation is weak. We have to start out by a strong foundation. We have to focus even more on writing clean, modular, and maintainable code. And you might think, well, seriously, this clean code thing again? That's all everyone is nagging about. But we're not nagging enough. We still have to focus more on writing proper, clean, modular, and maintainable code. Because we should view code as our means of communication. Code is how we communicate as developers, not only when we communicate with the computer, but when we communicate with other developers. We communicate through code. Yes, you have code comments, and you might write a comment when you check in your code, and you might have to document how your code works somewhere. But your main mean of communication with other developer is your code. Your code shows the intent. Your code should explain its meaning. That's how we communicate. But communication always fails, right? At some point, communication fails. So we also have to improve our ability to deal with other people's failure to write clean code. Don't rewrite code simply because it's easier than trying to figure out how it works. You should take that as a challenge. You should sit down and analyze that code. Try to understand it. You should assume that the developer who wrote that piece of code had a brain. And you should assume that that developer is actually capable of using that brain. View it as a learning experience. Try to understand what the previous developer is trying to tell you. What are they trying to communicate through this piece of code? I have made some of the results from this survey public. And next week, I'm going to make the entire spreadsheet public. So if you'd like to dig into the data and see if you can find other interesting correlations between the different questions, then you have the chance to. If you have any comments, if you have any questions, feel free to contact me. Other than that, I'd like to say thank you for having me.